Meditation is often associated with mental silence, but the reality is a state of dynamic modulation, the active optimization of a complex neural state machine. Functional magnetic resonance imaging provides a real-time window into this process. By tracking blood oxygen level dependent signals, researchers can map the shifting activity across the brain's distributed hubs as the practitioner cycles through distinct cognitive states. This model identifies 5 intrinsic networks governing internal thought and external attention: default mode, central executive, salience, dorsal, and ventral. They operate on strict polarity. The default mode governs internal thought, while the central executive and dorsal attention networks drive goal-directed focus. Mastery in focused attention meditation is the structural optimization of the Salience Network to route traffic efficiently between these two opposing systems. The Hasenkamp cycle identifies 4 distinct cognitive phases that repeat during practice, proving that the meditative brain is in constant fluctuation. The cycle begins with mind wandering. Control defaults to the default mode network, where the medial prefrontal and posterior cingulate cortices engage in autobiographical memory and future planning, trapping attention in a closed narrative loop. Meta-awareness emerges the exact millisecond the practitioner recognizes the distraction. This moment triggers the Salience Network, which fires a conflict detection ping that interrupts the default mode's inertia. This circuit breaker is driven by the anterior insula and the dorsal anterior cingulate cortex. These regions register the discrepancy between the practitioner's goal and their current wandering state. To prevent frustration from triggering the amygdala and derailing the cycle, practitioners often use affect labeling. Mentally naming the distraction, like planning, actively dampens the stress response. Real-time imaging shows that meta-awareness is a mechanical event. It is the moment the Salience Network acts as a neural alarm, preparing to override the default mode. Phase 3 is the shift. The Salience Network routes operational control to the central executive network, which sends an inhibitory signal to dampen the wandering mind. The dorsal lateral prefrontal cortex performs the heavy lifting here. It provides the effortful control required to physically uncouple attention from the internal narrative loop. This is followed by the relish phase, a brief moment of clarity that utilizes the frontal parietal nucleus accumbens pathway. This provides the structural reinforcement needed to stabilize the new attentional focus through dopaminergic reward mechanisms. Rerouting attention requires sheer prefrontal force to break the natural gravity of the default mode network. Finally, attention stabilizes on the somatic anchor, such as the breath. The dorsal attention network locks into a steady, pulsing rhythm with the central executive network to maintain this focus. In this state, the dorsal attention network establishes steady alpha-theta synchrony, functioning as the brain's sensory aperture. To maintain this aperture, the brain simultaneously suppresses the ventral attention network. This acts as a neural blindfold, filtering out involuntary bottom-up sensory distractions. Sustained focus is a highly competitive dynamic. The brain simultaneously locks its aperture on the target and actively filters out environmental noise. Comparing network connectivity reveals how this state machine evolves. Novices require massive prefrontal spikes, high cognitive strain, to deactivate the default mode. Intermediates maintain presence via rigid anti-correlations. But advanced practitioners drop prefrontal reliance. Posterior regions take over, allowing the networks to co-activate without friction. Long-term practice leads to a permanent, baseline reduction in default mode activity. This structural neuroplastic change indicates the system has automated the recovery protocol. Cumulative expertise physically rewires the connectome, translating effortful mindfulness into a permanent, effortless trait. This developmental arc moves the brain from top-down, effortful prefrontal control to automatic, bottom-up regulation. The advanced brain still experiences mind-wandering, but the detection and recovery protocol executes with zero cognitive friction. Mastery represents the deliberate architectural optimization of the human brain's intrinsic networks.